By the end of this presentation, you should be able to identify and define the three properties of equality, which are transitive, symmetric, and reflexive. You will be able to differentiate between the three properties and identify examples of each. What are properties of equality? The three properties of equality, reflexive, transitive, and symmetric, are used in geometry when working with statements about congruence. They're used in algebra when we're working with statements about equality. They may seem intuitive, as if you can use common sense, but they can be easily mixed up. So just make sure that you are finding ways to keep these in your brain. So as an overview, reflexive, I just think reflective, and you think of a mirror. So the fact that any quantity also equals itself, x equals x, or, you know, segment AB is congruent to segment AB. And it seems weird, why are we going to ever need to know this? But there's going to be some examples that come up in geometry in chapter 3 when we do our proofs that we're going to really need to use this as a step in the proof. The transitive property is the same as the law of syllogism, so you're going to think trans equals across. If A equals B and B equals C, then you can just say that A equals C. So I think if you can just think about like the B connecting being like the bridge or the connector between A and C, then that's like the trans, you know, transatlantic means across the Atlantic. So if you'd say, well, across from A to C, you have a B bridge, then you're using the transitive property. And then symmetric, I just think switch, and you can come up with another memory clue if you want to, but basically that one says if x equals y, then you can switch the equation around to say y equals x. And I know that that sounds like, why would you ever need that? Why would you ever need this? And why would you ever need this? But in geometry, it's going to come up. So we have to know these. Okay, so reflexive in words, any quantity always equals itself. And the symbols for equality, you can say x equals x, or you can say the measure of angle A is equal to the measure of angle A. Those are two examples there. Congruence, it's kind of the same thing. So segment AB is congruent to segment AB, or angle ACL is congruent to angle ACL itself. And so again, like I'm going to tell you, like we will come up to this and you will see that we're going to need to use these properties, even though it's weird. So I always just think of this, if this is a mirror here, then you're obviously going to like look at yourself in the mirror, you know, it's the same on both sides. But just, yeah, try to keep that separate than symmetric, which is a little bit different. All right, so there's examples. So it says spot the reflexive property in each row. So in each row, and I'm encouraging you to pause and just try to find them first. So there's 8 equals 8, x squared equals x squared, and x equals x. So those are the three reflexive property examples in this here. This one here looks like distributive property. This is distributive property, commutative, associative, inverse, inverse. Little review there. For the symmetric property, any equation is true, quote, forward and quote, backwards. Okay, so if you have an equation, then you can switch the sides of the equation, and so the left side becomes the right side and the right side becomes the left side. If AB is equal to 17, then 17 is the length of AB. And you can say that back and forth either way. If angle WGA is congruent to angle DJT, then angle DJT is congruent to angle WGA. And this is line of symmetry, so this is a little bit different than reflexive. So reflective, think mirror. It's only one thing. It's one thing equal to itself. But the symmetric property is going to have two, it's like an if-then, right? So the reflexive property is just one, something equals itself. Like you're looking in the mirror and the equal sign is the mirror itself. For symmetric, then you're going to have an if-then. So if x equals y, then y equals x. You have to have two equations for symmetric. So when you look, the equal sign is also being reflected across this line of symmetry in a way. And this is just pictures. I just picked symbols to try to visualize it for you. All right, so, spoiler, spot the 4 examples of the symmetric property in the chart. So this is one example of symmetric property. There's 3 more. So it says if 3x equals 15, then 15 equals 3x. So you can pause this before I reveal. All right, the next thing is if 3 equals r, then you can switch around the equation, then r equals 3. If 5 equals w, then w equals 5. And then this last one doesn't have an if then, but if 50 cents equals 5 dimes, you could say that 5 dimes is equal to 50 cents. This one here, this one's example of distributive, and I'm not going to spoil those. This one's distributive as well. Lots of distributive property in here. All right, transitive. Two quantities are equal if there's a solid bridge between them. Okay, so I could have written something else. I could have written something like, if one quantity is equal to the second quantity, and the second quantity is equal to a third quantity, then the first quantity is equal to the third quantity. I just don't like to write it out that way. So two quantities are equal if there's a solid bridge between them. This is if A equals B, and if B equals C, then you can just say, okay, well, instead of using B as a bridge between, instead of saying both of these statements, I can just cut to the chase and go across from A to C, and that's just my statement that I'm allowed to make. It's a conclusion I'm allowed to draw. If angle A is congruent to angle B, and angle B is congruent to angle C, then you obviously know that angle A is also congruent to angle C, so you can just cut to the chase. So the transitive property here, I did A equals B equals C, and then that means that you can also say that A equals C, and it's like a really long equal sign that I made look like a bridge, so hopefully that kind of lands in your mind. And then what type of deductive reasoning is this? So there's two. There's a law of detachment, and there's the law of syllogism. So you have, this one is, you have a bridge in between. It's not detached. There's a link. So it's the law of syllogism. So transitive property is just using the law of syllogism. So if you're talking about those things, you're really speaking about the same thing. Okay, so we're going to spot the three examples of the transitive property or the law of syllogism in the chart. So we're looking for, and this is long, we need 3 equal signs, you know? And so for reflexive, it's 1 equal sign. For symmetric, you need 2, and then for transitive, you need 3. So we have, if 3 equals r and r equals 2x, then we know that 3 equals 2x. If m equals n and n equals 3p, then we know that m is equal to 3p. We can just go across the ends. And if 2 divided by 2 is equal to the number 1, and if the number 1 can be written out as O-N-E, then we know that 2 divided by 2 is also O-N-E. Okay, summary very quickly. Okay, so when you have the reflexive property, you're going to be thinking mirror. There's 1 equal sign. A quantity just equals itself, like it's looking at itself in the mirror. Transitive means across, so A equals B, B equals C, then you can cut to the chase, A equals C. And then that's the law of syllogism. And then you can think switch. If x equals y, then y equals x. And for symmetric, then you can think there's 2 equal signs there. So that's another way to remember it. 1 equal sign, 2 equal signs, 3 equal signs.